Hey everybody, welcome to day 3. Last time we did a bunch of decorators and we went over the basics of Pytorch. And now we'll start with just importing torch. Let's start. So for importing Pytorch, you just do import torch. After that, you got to just go ahead and let's make a one-dimensional tensor, right? So I'll call this as a 1D tensor. 1D tensor, okay, is equal to torch. Oops, torch dot tensor. And now we can put whatever values we'd like. So I'll put 1, 2, 3, 4 as usual, right? And now if I print this, print 1D tensor, you're going to get a tensor, an object which is a tensor, okay? Just give it a moment. Yeah, there you go. So it's made a tensor over there. There are other ways to fill up that one-dimensional tensor. You can do torch dot zeros, okay? So this will fill it up with zeros. And let's say I want at least 4 spots. I'm going to do 4. I'm going to say 1D4. Okay. So I can call this, what do you call, tensor 1D4. Okay. So all I'm saying is it's a tensor of one dimension. This is a random variable. Don't pay too much attention to the names that I have done over here, right? And let's say I put torch.2D. So if I want a 2-dimensional array, I can just do 2D. Okay. Actually, before 2D, let's do once. Torch.once will make it once, right? If I just do this, you'll get it 0, 0, 0, 1, 1, 1, 1. If you observe, it'll make it a float value. Ta-da! You see that? It's like a floating value, right? And now let's continue. Okay. Tensor 2D. Okay. You can do whatever you want. You can just make whatever. So you can say torch dot tensor of, I don't know, 3. Oh, oops, I wrote a test now. Ten tensor 3 comma 3. Oops. Actually, you know what? Let's actually do the first thing manually. So let's say I want to make a 2D tensor, then it's a list of lists. So I can make, so it's like a 2D tensor. So here it's got to be maybe 3 cross 4. So that means 3 on the x-axis, 4 on the y-axis. So, or maybe 3 cross 4 will be a lot of writing. Let's do something smaller. Let's do, what do you call, 3 cross 2. That should be better. So I'll do 1, 2, 3. I will do 4, 5, 6. So it should be one below the other, right? Now if I do over here, print tensor 2D, let's see what we get. So we get a 2-dimensional tensor, okay? Now the other part that we need to do is shape. Shape is very important. So we want to find out different types of shapes. All you can do is you can just do this print. Whoopsie. Oh, would you look at that? I mean, whoops. Where do I have? Okay. Print tensor 2D shape. So now you can actually see the shape. It's 2 comma 3. 2 comma 3. Yeah. Now let's further do more stuff. Okay. Let's go for common tensor operations. So tensor zeros and ones we went over. We can, oh yeah, let's actually show you two-dimensional. Okay. So print torch dot zeros of 3 comma 3, or rather let's do 2 comma 3. Okay. Print torch dot ones. So you will just see what it means. So that means there are 2 rows and 3 columns. That's all it says. Okay. So 2 rows, 3 columns. You can see that. And the other thing is you can add tensors if they're of the same dimension. So we could do this and this, right? We could do tensor 1d4 plus is equal to, so no, equal to tensor 1d4. Oh yeah, you can also reshape if you'd like to, but let's not go there yet. Wait. Before we reshape, let's actually try to just do basic addition, right? So I wonder if tensor 1d4 plus, okay, another tensor with 4 variables, we'll go with 1D tensor over here. Okay. So now, what do you think do you think this will work? Because 1D tensor is 4 objects. Tensor 1D4 is also that. So now the updated value of tensor 1D4 should be, whoops, I mean, of course it will work. So the updated value of 2 star, let's see if this will work. Okay. Look at this. So what we have done is we have just done tensor 1D4 is basically 0, 0, 0. So it's all 0 plus 2 times 1D tensor. So 2 times 1, 2, 3, 4. So that's 2, 4, 6, 8. So the answer is 0 plus 2, 4, 6, 8, which is 2, 4, 6, 8. There you go. So you can do all these normal operations, addition, subtraction, multiplication with tensors. You can also do dot products, right? So you can say dot product is equal to torch dot. Okay, so he's saying 1D tensor star 1D tensor 1, 2, 3, 4 star 1, 2, 3, 4. What do you think this will give? This will give a single value. Why? That's because it's actually doing matrix multiplication. So matrix multiplication would be basically 1, 2, 3, 4 star 1, 3, 4. But actually, this would be vertical. This would be the transpose of this. So it would be vertical like this. And what will happen is it will become 1 times 1 plus 2 times 2 plus 3 times 3 plus 4 times 4. So if I were to just say matrix determinant multiplication dot product, you will basically see what I mean. Okay. So it's basically this. It's basically this. If you all can see it, it's basically AB CD star WX Y Z is basically AB into the first two elements. So this two into these two, that is A times W plus B times Y plus AB into XZ, so on and so forth. In our case, because both of them are one dimensional, it just was a single multiplication giving us one value, right? That was what was happening. For example, I can show you something else. Let's take another vector, which is, hold on. Let's take one more, let's take one more vector. And this time we will create a vector which is 2, which has basically 2 different parts, right? So here, instead of 1D tensor, we can put, one sec, multiply tensor torch dot. he's making me multiply random stuff. That is Google. So just give me a sec. I think we're already in the 8-minute mark. Let me try to quicken this. Okay, getting back. Sorry for the quick this thing. Basically, what the dot product does is basically, I myself had forgotten a bit. It's not matmul. It is torch dot dot. Basically, takes 2 one-dimensional tensors and multiplies them and gives you a single value out. And the number of elements need to be the same. So, for example, if I were to put this 1D tensor, this is a 4. This tensor is basically 4, 1, 2, 3, 4. But this is 1, 2, 5. This is just 3. So there are only 3 elements in this. This will not work. This will give me an error, right? So you need to make sure that this is the same amount of elements. And when we multiply it, it's basically 1 times 1 plus 2 times 2 plus 3 times 3 plus 4 times 5. So 4 times 5 is 20, 3 times 3 times 3 is 9, so 29, plus 2 times 2, that is 4, that is 33, plus 1 times 1 is 1, so 34. So the expected answer for this is also 34. So if you look at it, yeah, it gives you the tensor value of a single 34, right? The other value operation that I wanted to tell you about was the multiply, right? Multiply tensor is equal to, so what we're going to do is we're going to multiply tensors. And this is going to be not a scalar multiplication like we did before, like here, okay? But it's going to be a vector multiplication, okay? So we use the matmul, mat matrix multiply to actually do that, where we use m cross n and n cross m, and those two values must match. What I mean to say is, over to right over here, matrix M star N root. Okay. So it'll actually show it to you. I think Wikipedia is really good at this. It's basically you multiply two vectors. Wait, matrix multiplication rule. Yeah, matrix. Wait, matrix multiplication. That's it. So you need to just know this. Yeah, this is it. So if the dimension of matrix is m cross n and its b is n cross p, then the final thing will be m cross p. So this is basically what you need to know. It's pretty simple. It's pretty straightforward. It's basic math that you'd have done before. So right now what we can do is we can actually go to the documentation itself and just search for it. Like if you know what it is, then you can just do it. I do here matmul. Okay, so we got chain matmul. I just want normal matmul. So if you go to, it takes an input, other output. So it behaves on the dimensionality of the tensors. If both tensors are one digit, then the dot product is given. Okay. If both arguments are two-dimensional, then the matrix product is returned. Okay. And if the first argument is one dimensional, the second argument is two-dimensional, one is prepended to the dimension for the purpose of matrix multiply. Okay. So basically, if it's just a single value, they add another one prepended. Okay. And after the matrix, the prepared dimension is removed. Okay. This is sort of crazy how they do this. But this is basically how the function is, right? If the first argument is two-dimensional, the second argument is one-dimensional, the matrix vector product is returned. Okay. So two-dimensional means 3 cross 4 cross 1 cross 5. Then the matrix vector product is returned. You know what? We should just try this. If both arguments are at least one dimensional, so there are weird rules. Okay. It's very important that you actually go through the documentation once, so you get a good understanding of what's going on and how it works, right? Oh yeah, there's also the random function. I completely forgot. Torch.random, right? So you could also wait. Let's actually make a random tensor. Okay, rand1 is equal to torch.randn of how big do we want it? We want it to be, let's say 3, right? Print rand1. Okay. And for multiply tensor, as I was saying, let's actually do the matmul operation, right? Let's do torch.matmul of. So this is going to give me a 1 cross 3. Wait. So we first look at what matmul does. So look at this. So it's given me a random tensor. Okay, completely random value. Tensor of -1, -1.7, 0.96. So it's given me a 1 cross 3 tensor. Okay. So if I give it a 3 cross 1 tensor, then I should be able to do matmul properly if I give 2-dimensioned this thing, right? So I'll give you an example of a 3 cross 1. So I can just do rand1, comma. What's the other tensor? The other tensor will be, I'm just going to manually do torch.tensor on this. Torch.tensor of a 3 cross 3. So this will be like, I don't know, like maybe 2, comma 2, comma 2. Okay. Whoopsie. Sorry. 3 cross 1 is 2, comma 2, comma 2. Yeah. Okay. So now I'm going to do print multiply tensor value. So what we'll expect is that multiplied by 2, 2, 2, 2, added up together, right? And you can easily get the answer, right? So you have the tensor. Oh, okay. What happened? Expected M1 and M2 have the same D type but got float. Yes. So if you recall, right, but got float not equal to long int. So one is long int, one is float. This I believe is long int. So you got to actually you got to typecast it into float. And I'll tell you how to do that. Okay, guys, even I revised a bit myself. I used Gemini over there to help me out. I had forgotten quite a few things. So this is rand2 3-dimensional. So torch.tensor, this gives you that. Now what you want to do is you actually want to find out the shape. So if I were to multiply, this will not exactly work. So if I were to press this, I would get an error. The error being M1 and M2 are not the same type. They got a different type. He's saying got float not equal to long int. That means the first one is float and this is not equal to long int. That's the second one. Second one is rand2 3-dimensional. So this should actually work, but it's not working because the types are different. So first, let's investigate a type. So to investigate a type, we can just do rand. Okay, so I've shown you shape. So shape is the shape of the matrix. You can also get print rand1 dot d type. You can also actually get the device if you'd like, right? By default, I believe it will be CPU. Okay, so first let's get the d type. So if you see here, you can see that it is CPU and it's d type. CPU means all of the memory of the array is stored inside the CPU memory. If you change the device to CUDA or GPU, then it goes into the GPU memory of this instance. Currently, I'll just leave it there. We won't go there. We will touch this later, the device part. But what you need to pay attention to is the shape and the d type. So the shape is obviously 3x1. So torch.size. That is 3. He's given 3. Right, it's just a one-dimensional. And now, what we'll do is we will convert it into same type. So to convert it to the same type, we have to do dot 2, okay, and then we put over here d type. D type, here we have to pass an object. We should not pass a string, okay. So we passed a float 32. So if I pass a string, it would go wrong. It has to be torch.float32, which is the same as this. It should be the same object as this. So now it has, changed. So now if I do this dot, okay, we want to find out the d type. So put d type over here. Okay, so now it should give us the same d type. And if they are the same d type, then this error will not happen. So in theory, then this multiplication should work. There you go. So the multiplications work. So it's 3 cross 3, like that. So it's working, right? In fact, you can make 3 cross 2 as well. So I can make it like 2, 3, 3, 3, or rather 1, 1. So basically, it will be an addition of all these 3 values if I were to do that. So you will just have a look. There you go. So you got 2.29 plus 1.1064, which is basically 0.107 plus 0.96 minus 0.04. So this will become 0.92 plus 0.17. So that's like 0.99 plus 0.1. That's like 1.1. Oh, perfect. So we got the value almost. We got the perfect value. So we can ascertain that this is type. So for now, we will stop today. This is the basic multiplication and multiply tensor, the matmul operation, the shape operation, as well as the d type. You can find the type that it is. Device, you can just keep it in your head. Torch multiplication you can do. You can make 2D tensors, 3D tensors, whatever shapes you want. These are shapes. We will go to reshape and recasting later, but this is what you need to know for today. Okay. Thanks a lot. See you tomorrow.